Hi everyone. So today I want to give you a story that started in 2008. So I've always been fond of playing video games, but I think that even more than playing video game, what is fun is creating video games. And so what I started this year was a software. It's called GDevelop, and it allows you to create. It's an open source software that allows anyone to create video games. So how it's working, it's quite simple. You have an editor for games so that you can create the levels of your game, add your objects, and then you have some kind of visual programming. I will show you how it works, so that anyone, even people that are not developers, can actually go and create all the rules and the logic of their games. Games are outputted as HTML5 games so that they can run on the web, but also on iOS or Android. So that's how it looks like. Well, it looked like, because that's the previous version that was created all in C++. So all that you're seeing is a C++ interface that I started using a UI toolkit. So let's see how it works. I want to, in this game, I want to add a button, and when the player steps on it, the button is pressed, and then the platform is going up so that the player can continue. So let's see how it works. I put the button here, and then in the events, I'm adding a new event composed of one condition. So a condition is like a if. So when there is a collision between, let's say, the player and the button, yes, here it is, then I will launch two actions. The first one will be to change the animation of the button so that it's going to the first animation, well, the second one, which is the pressed state. And then I'm adding another action, which is the one to move the platform up in the air. So I choose the platform and add a force so that it's moving up in the air. Then I can press play. The game is generated. And when I step on the button, yeah, it's going up. So that's working fine. And as you can see, it's pretty simple so that anyone can go ahead and create games like this. There are also a bunch of predefined behaviors for people that want to get started quickly. And using this software, a few games have been created. I did the one with the cat, by the way. And you can download it. It's called Lil Bub. Anyway, it's working quite well. And as it's open source, I've been working on it since all this time. Now, fast forward in 2016. At this time, I was like, the editor is getting quite old. I had a lot of cross-platform issues with the UI toolkit, so random crashes on macOS and Linux. So I didn't know what to do, and iterating on the software was quite slow. Well, it's C++. Building UI was slow too, and I was limited to all this kind of old UI components. It's native, but still, you can't do everything that you want to do. And honestly, the UX wasn't so good. Everyone was telling me, it's a bit complex, even if it's for beginners. And well, the entry barrier, was quite high for new contributors, C++. So yeah, it was time for a change. So what do we want? First, we want a new editor, which is cross-platform, have a better UI building paradigm that allow a faster development, a lower entry barrier. Well, all that I've said, but better. But I don't want to rewrite all of this. Why so? Because I want to keep the full compatibility for the existing projects. I don't want to recreate a new game engine. I spent years doing it, and people won't be, users won't be happy to have to rewrite their games. And well, nobody got time to wait for a rewrite. There are games to be made. So the question was, could the web technologies help? Well, let's see. Here is the C++ code base that was existing. So it's basically the core classes that are describing what a game is, what are the texture, the objects, and all the classes that are doing the code generation of your game. And then I had also all the graphical user interface and the file system. So all in C++, I was using this toolkit called WX widgets. So the idea is, can we port this to a new editor? For example, instead of using this UI toolkit, we could instead go and use React. React, for example, and have for the file system Node.js or browser adapters to write to files so that it could run on Node.js, Chrome, or something like Electron so that you have a desktop application. And for the core classes, the idea was not to rewrite them because if I look at this, I have to rewrite the interface, which is already something that is quite time-consuming. So how to do for the rest? I want to have a library of my classes that I wrote in C++. And for this, we could use Emscripten. Before explaining how it works, let's talk about WebAssembly. WebAssembly, it's this new. Well, it's not quite new. It has been a specification for a few years, and now it's a real thing. It's a low-level language running in your browser. It's assembly-like. It can be compiled by all major browsers like Safari, Edge, Chrome, and Firefox to machine code so that it's really fast. And it's something that you don't write directly. It's a language that you compile to. And for compiling to this language, we can use Emscripten. So how it's working, pretty simple if you look at it from far. You take your C++ code base, and what Emscripten is doing, that it's running your code base through Clang, which is a C++ compiler. Then Clang is outputting bytecode called LLVM intermediate representation. And instead of moving this code to traditional assembly and have a native binary, what Emscripten is doing is it's like translating this bytecode to WebAssembly. So pretty easy, and it's working. How it works? Like this. You can just clone the EM SDK, install the latest toolchain, and then in a few minutes, you are able to use and run this compiler called EMCC, which is how can I say, a wrapper around all the toolchain that I've shown, and compile a C file down to WebAssembly and JS. For larger projects like mine, Emscripten is giving you a few, how can I say, a few toolchains that you can use to replace CMake or AutoMake, so that it's a drop-in replacement for your compiler. So at the end, instead of having your executable file, you get your WebAssembly file and the JS. So then how it works, because we are able to compile something to WebAssembly, but we want to be able to reuse the classes that we've done in C++. So for this, let's take an example. I have this first class in C++, which is an objects container. So it contains the list of objects that you've seen on the game. And then there is the layout, which is inheriting the objects container. And the layout it's a scene, it's a level in your game. So it has a name. We want to expose this to JavaScript so that we are able to use it in our software. So what I've done is that I've written WebIDL bindings. So WebIDL, it's a language, and Emscripten is providing you a tool called WebIDL binder, which is running through your bindings and generating glue code between the C++ code base, well, the WebAssembly, and the JavaScript, so that you get the same classes that you had in C++ in JavaScript. You just have to be careful about a few things like reusing the good type, but I will explain. So how to use it? You first have to instantiate the module that was generated by Emscripten, and then you can create objects much like in JavaScript. So you create, for example, a new layout, set the name by calling the function setName, and then same for all the other classes that you expose. So it's pretty idiomatic JavaScript, except for a few things that I will explain. First thing is that primitive types are converted, so doubles, numbers, strings. All of this you can reuse them without conversions. For object references, they are converted to pointers in C++ or references. So again, it's okay for most code base. It's a bit of a pain if you're using smart pointers in C++. But in this case, what I've done is that if I have an interface that is dealing with smart pointers, I will hide them with classes, with methods that are only taking references. And finally, things like the input-output stream in C++ are binded to console.log so that you get something that is working almost directly. And this is what you can see in your browser when you're running the code base. So I was able here in the Chrome debugger to create a layout, to call a function on it, and to get back what I've set. So when you have this, when you have your code base that you created a few years ago in C++ that is running in the browser, you're like, yeah, it's really working. It's not. I'm not joking. Yeah, Star Wars Episode 1. Sorry. So a few things to know, because it is not that simple, of course. First, memory management requires care. Why? Because we are using C++, no garbage collector. So when you're creating something, you have to destroy it. So it's not complicated at all. You just call gd.destroy or your module.destroy, but you have to remember to do it. Otherwise, you're leaking memory. You're leaking memory in the WebAssembly world. For React, well, if you have a component did mount where you're creating a new object, remember to delete it when the component will unmount. Pretty simple stuff, but it's super easy to forget about it. And there is something to know, that the output files can be quite large. Like it's 3 megabytes, I think, for gdevelop. But honestly, I don't care. I'm creating a desktop application, and people are happy to download the 100 megabytes. So yeah, 2 or 3 megabytes, more or less, are the same. Other thing to know, yes, have a test set for your library, because I remember that I started with some bindings that were not WebIDL, then I moved the whole thing to WebIDL, and if I have not this test set, I wouldn't have been so confident in the fact that it was working. And the thing is that this is the kind of error that you get when something is going wrong in the WebAssembly world, which is pretty helpful. It's not, of course. And it can happen for quite a few things, like if you send the wrong type of parameters, if you forgot a parameter, if you're using a deleted object because you've called destroy and then reuse for some reason your object. So be extra careful, and you don't have this garbage collector that will prevent you from doing bad things. So yeah, that's the bad part. But at least we now have something that is all the core classes of my code base that is running inside the browser. So first thing done. Now let's see what we can do for the interface. And we could use React. So I will explain a few patterns that I've used to recreate the complex UI of the software on the browser. And for this, the first thing to do is to find a good component library. So the idea is that I want to recreate the whole interface, which is a hard and long step, but I don't want to spend time recreating all the classical components that you're using. And by classical components, I mean all of these. So list, context menus, dialogues, thumbnails, the text fields, of course, and all of this is quite long if I have to recreate all of them. So what I've done is that I went ahead and see what are the libraries that are available for giving components out of the box. So there is Material UI, React Toolbox, Blueprint, maybe others. The one I've chosen is Material UI, mainly because it was the one with the most extensive list of high-quality components. By high quality, I mean lots of props, flexible, all these things. I've seen that Blueprint has re-evolved a lot and is giving you a lot of different widgets now. So it's up to you. What I'm also looking at is, can I change the theme quite easily? Is there a support for nested dialogues? Because the software is quite complex. So as you've maybe seen, at some point I'm opening a window and then opening another one inside. So it's not like I cannot open new web page for my windows. So I need nested dialogues. Look at the flexibility of components, as I said, the quality of the documentation, and something to see is that blazing fast? Yes and no. So yeah, just look at the benchmark, because if you have a quite complex UI, it could be helpful to have something that is performant. Next thing to see is I want to display quite large list with drag and drop, and this list can be from dozen to hundred of elements. Here, for example, it's the list of objects. The answer for this was to use virtualize list. So for example, I've used React Virtualize plus this library called React Sortable HOC. So the idea is that instead of having your list, which is just a dot map on the row of the list, you're wrapping it into React Virtualize and React Sortable HOC components. So what you're doing is that your object row, you're putting it into a sortable element, and then your object list, you're changing it to, instead of doing a dot map on your list, you're using a list, which is something that is provided by React Virtualized, and you're giving it the row renderer, which is your sortable object row. And then you finally have to wrap all of this into a sortable container, and you get a list that is both virtualized and sortable, so that you can drag and drop elements. Virtualization was really important here because whenever I'm displaying the list of objects that you've seen, I'm making call to WebAssembly, which has a small kind of overhead. So I want to be sure to only pay for what is on the screen. Next things that I wanted to do was to have movable editors. So you see the panels on the left that were in the native application, and I wanted to have the same thing in my new application. So the thing is that editors for games are quite complex, and people like to make their own workspace and move around the editors. What I've used here is React Mosaic, which is done by Palantir, and what they've done is a really nice library to move windows like this. So I just had to change the theming, and that was all, well, almost all. So that's something that is really moving your application from, this kind of web app to a real application that is like a desktop one. Speaking of things that people accept in desktop application is the keyboard handling. So you want to have shortcuts, but also to have a proper focusing of your elements so that you can go through a big form like this using only the keyboard. So for the focusing part, it's pretty simple. Just make sure that your components, when they are mounted, they are able to focus their first field. Depends on what you're doing, but that's something that users really appreciate. And for shortcuts, I've seen the implementation of Blueprint.js to be quite good. They're making this hotkey component that you can add in your render. Well, it's not really in the render method, but it's in another method provided by a decorator. Anyway, the approach is quite beautiful, I think. I'm not using it. I'm using a homemade solution where I'm listening for keyboard press and then mapping it to the function of my component. But still, I might move to this. And again, the idea is that it might be okay for a website or a web page not to have shortcuts, but it's not something. It's something that people will accept for a desktop application. Let's finish by something that is a bit complicated. That's this large tree, which are the events of your game. So on the left, this was the implementation in native. So I had this custom code that was rendering everything. That was a real mess, like a 2,000 line of C++, unmaintainable. Wonder who done this. Anyway, so here the answer to get what I have on the right is also virtualization. So here I've used something called React Sortable Tree, which is also based on React Virtualized. It's quite interesting. Every node that you see is actually a row of a list, and the connection that you can see between the nodes are actually, how can I say, they are drawn for each line of the virtualized list. So, well, it's working quite well, and with a bit of tweaking, I was able to recreate this visual programming, and I even have this awesome drag and drop, which is working also quite well. If you want to display at some point something that is a bit more complex than just lists or trees or forms, you have maybe to, in my case it was the level editor, you might have to forget about the DOM. So the answer was here to use WebGL with a library like Phaser, 3JS, or Pixie. I'm using Pixie. because it's the library that I'm using for rendering the games. So I'm also using it for rendering the level editor. So if you're making things that are getting really complex, might be a good idea to switch to this, but it's not always the case. The DOM can still be good enough. For example, if you have a visualization of an object, and here what I'm showing is the editor when you can create the collision polygon of your object. And here it's all done using SVG. So SVG, polygon, and all the standard components that are offered by React. So it's working quite well, and there is even support for drag and dropping the vertices of the polygon using this on mouse move, on mouse up, and on mouse down, so that you get something that is almost like an editor, but in the DOM. You could use, by the way, on pointer rather than on mouse to support touchscreen. Then when things are not native enough, for example, context menus. I think that's the thing that makes really difference between a web app and a desktop application. Here is on the left, the implementation of the context menu by Material UI. It's quite good, but when you've downloaded a software, you're expecting to have native context menu, like on the right. So what I've done here is to reuse the Electron API, because my software is bundled in Electron. It's huge, I know, but I don't care. And, and so the idea was I want to still be able to use the software on the browser, because it's quite good for users to be able to try the software in the browser, then download it. So I just built an abstraction over the context menu. So it looks like this. I either create from a template, a JSON template, I either create components from Material UI, or I call the native API from Electron. So in a way, I've adapted Material UI so that it's the context menu can take the same template as Electron. Yes, that's it. I think that this thing can also, so here it's for context menu, but there are also things like the title bar, the top level menu that are important to get as natively as possible, but Electron is providing API for all of this. Then sometimes things are not going fast enough. For example, when you render your application, one thing to always check is how is the rendering of the components. It's the number one issue when things are not going fast enough. So I've used at the beginning, why did you update? Which is quite interesting because it's patching, it's monkey patching React and telling you after every update if a component was re-rendered but has not changed. So it wasn't useful to re-render it. So it was a first step in finding all these components that could be improved to have not to avoid being re-rendered. But the thing that was out like a few weeks ago was the new profiler in React, in the latest version of React. And I've used it, and in a few, I would say, in less than 1 hour with it, I understood how it was working and was able to find that something was re-rendering when it shouldn't have been the case. So if you see the flame chart, I was switching from one tab to the other, and I've seen that there is one part of the flame chart on the left that is colored, meaning that it's re-rendered, and it was the project manager which was hidden. So I was re-rendering hidden things. The answer was to add a should component update to make sure that when props are not changing, then the component is not re-rendering. It's often the answer. And last thing to remember when checking about performance is to always do it in production build, because I've spent, I would say, like half an hour wondering why the drag and drop wasn't fast enough, like it was 1 or 2 seconds, like really too much when moving something. And in fact, when I switched to the production build, it was like instant. So yeah, remember about development build is way slower. The other thing that could slow down your application back to the WebAssembly world is the calls to WebAssembly. So beware of the overhead that you have every time you're calling WebAssembly, or because there is the time for going from the JavaScript world through the WebAssembly world. I've not measured it, but I know that in case you have a list of objects that you're filtering. So getType is making a call to WebAssembly, and then you're calling .map on this list to get something. So here, get variables is also a call to WebAssembly. In this case, can put a lot of stress on the rendering. So it won't be noticeable in most UI situations, but if you have tons of objects, for example, if you're rendering this virtualized list of 100 of objects, it can feel slow. So the idea is that it might be useful to either store strings or values on the JS side, so you can go over it full speed. I think that's all for the performance side. So now let's see how it looks like last year. So here is the result. So here I'm doing the same thing, except that I'm creating the object that is the button. So I'm adding a new button, then adding the animation for having the button pressed, and then doing the exact same thing as before. So I will add an event so that when the player is stepping on the button, then the button is being pressed, and then the platform is going up in the air. So it's to show you, well, what it looks like now, and it's the same thing, but better. So again, I add an action, which is this time the force, so that the platform is going up in the air. Adding the speed in pixels, and then the final action to change the animation of the object to be the pressed one. So I just select the button, I press play, WebAssembly is compiling, and then boom, I got the same thing. So yeah, that's working, and the advantage of having now this application made in WebAssembly plus React is that I got ultra-fast iteration. This is the compilation in C++ taking place every time you're making a change versus the output of Webpack after a few seconds. So that's really something that helps you to move forward fast. The other thing that I found useful was to use this thing called Storybook, because instead of having to relaunch the application every time I'm working on a component, I can just have it in Storybook. It's also a good way to have visual testing of your components. I'm not doing a lot of unit tests on my components because no time for this. But I'm doing a lot of Storybook stories, so that when I'm upgrading to a new version of Material UI or anything, I can go through all the components quite quickly and do my own integration test. Something that I get also for free with React and WebAssembly, it's that, well, it's using Electron Builder, that I get all this auto-update and packaging and code signing that is done for me for my application. And before it was a pain, even the native world, it's not something that is easy to do, but Electron Builder is doing all of this for you, so that I get this kind of auto-update for free since the day one. So since the day one, the packaging and the distribution of my application was much better than what I used to do for the old native application. And instead of making a new version every month, well, every 2 months, 3 months, I used to move to weeks or even days between the release, because I could upload a new version to GitHub in one single command line. So it's something that is really changing, and users are really appreciating that when there is a bug fix, I could distribute it in a matters of hours. I think it's like making an application, but which is like a website, because you can almost update it instantly, unless you've deactivated the auto-updates. And more things that are really nice, like I got more contributors than before, because JavaScript. Startup time is quite similar, even if it's WebAssembly, and you might say, oh, you have to initialize Chrome. It's similar, like 2 or 3 seconds. And people can try the software directly in their browser. That's the best part, so that they don't even have to download it. They go on the website, they click on try it online, and they can try it now. I even added in the documentation link to examples, so that you click on the link, the software is opening in a new tab, and the example that you've chosen is directly opened. So how cool is that? And later, I could even port this to iOS or Android tablets, maybe even phones. It could work on the phones. I have it on my phone, by the way. Who made this? Well, so yeah, it's not really usable. So I'm not advertising it as something that you can use on your phone because it's really, the screen is too small. And a few things are not yet ported for touch screen, but it could work. And also we could think about integration with Dropbox, Google Drive, all these things. I want to close this story by a plot twist, which is that I'm not using WebAssembly. All of this is still JavaScript. So the idea is that Emscripten, when I started using it, was compiling to this thing called asm.js, which is a subset of JavaScript which can be optimized by browser. It's much like WebAssembly before WebAssembly. And the thing is that I've not updated the build to use WebAssembly because it's working well right now, and I don't need the performance of WebAssembly. So it's good enough, and I will update it later to WebAssembly to get a bit more of performance, but really I don't care, and nobody's telling me that the software is too slow, so that's good. The last thing in my story is what are users saying about all of this? Because I will be honest, when the first version were out, people weren't that happy because it was missing a lot of features from the existing software. And the thing is that they were complaining not because I was using Electron, not because I was using WebAssembly or React. All of these things didn't matter. They were complaining because features weren't there. And after working on adding these features, I got some really good feedback, like what a difference a year can make, or amazing how much easier and streamlined the engine has become. That was 2 days ago in a YouTube video. I got the conclusion for my talk. That's a new user, but even people that have been using the version 4 of the software are now telling that the version 5 could be more productive because the UX is better, basically. So that's all for me. Yeah, you can find me on Twitter. My name is Florian. I'm working at Facebook. Feel free to ping me. You can try the software on gdevelop-app.com. It's on GitHub, and I wanted to show in this talk that we are able to make ambitious applications using React, ambitious application on the web, but also on desktop, and that it's even better than what we used to do in the native world. So yeah, thanks.
Thank you, Florian.